log odds, again, it's kind of a confusing, I mean, I don't know really how to interpret a log odds. There's no intuitive value to it. So instead, we can calculate what's called an odds ratio. This is a slightly different odds ratio. And conceptually, it's similar, but it's a little different. I'd actually like to call it the logistic regression log odds ratio, just to keep it clear. But what the odds, we can calculate we can convert that regression coefficient to an odds ratio by taking E, that same natural with a natural 2.71. Take E raised to the power of the regression coefficient. And that gives us the odds ratio for that variable. So we'll see in kind of we'll go through an example to see what I mean by that. So E to the power of the B, and you'll hear me, I'll kind of talk about that. E raised to the power of the B. You might see it written in computer output as exp parenthesis B. That's just another way of saying that's E raised to the power of the B. Is the increased odds of the outcome with a unit increase in X. That's more interpretable. Instead of the increased log odds, it's the increased odds of the outcome with a unit increase in X. So for every year of education, what's the change in the odds of a child dropping out? No, it's not the same as the odds ratio we described earlier, because that was just talking about kind of the very static, this group versus that group. Now, with logistic regression and a continuous predictor, it's one unit increase, another unit increase, another unit increase. And because of that, the scaling of our independent variable, just like with multiple regression, the scaling of the independent variable matters. If I want to look at the increased odds of a child graduating or not dropping out, or dropping out, kind of how does that change with 1 year education? That's a lot of education, and so the increase or the decrease in the odds could be fairly big. But what if instead I change my scaling from the change in the odds for one additional day in school? 1 day makes no difference. So the odds ratio is going to be very small because it's all tied to the scaling. But so that's the scaling of your, just like with multiple regression, the scaling of your independent variable matters. You need to pay attention to the scaling of the independent variable. Kind of how to interpret this in a way. What's also kind of different with the odds ratio, if the regression coefficient equals 0, E raised to the power of 0 is 1. Anything raised to the power of 0 is 1. So E raised to the power of 0 is 1. If the regression coefficient is 0, the odds ratio is 1. Now think about that for a second, and it makes a little sense. What's a regression coefficient of 0 tells us the variable has no effect, right? It doesn't change, the outcome score doesn't change at all based on whatever X is, it's still the same as predicted score. So B equals 0 means there's no effect. An odds ratio of 1 means what's the increased odds of dropping out with a unit increase? Well, the odds are 1 times it's changed by, it's exactly the same. It's exactly what it was before. My odds have increased by a factor of, I should have flipped these around a little bit because it's multiplied by 1. My odds, so if my odds are, it's now, I take the previous odds, now I multiply it by whatever the odds ratio is, it's times 1, so it's the same odds. I go up another unit, times 1, it's the same odds. Times 1, it's the same odds. When the regression coefficient is 0, the odds ratio is 1, and an odds, kind of keeping in mind, an odds ratio of 1 means no effect. So that's where odds ratios are a little different than regression coefficients. A regression coefficient of 0 means no effect, but an odds ratio of 1 means no effect. There's no difference. As you increase, the odds stay exactly the same. If the regression coefficient is greater than 0, so if the regression coefficient has a positive value, e to the b is going to be greater than 1, so the odds ratio is going to be greater than 1. So if my odds ratio is say 2, a unit increase and my odds now are multiplied by 2. My odds double. Another unit increase, the odds double again. Another unit increase, the odds double again. So kind of notice that. I'm talking about double, double, double. So the odds of the outcome get higher and higher with every unit increase. And the odds ratios are greater than 1. So odds ratios greater than 1 kind of correspond to a regression coefficient greater than 0. If the regression coefficient is less than 0, which is a negative effect, right, when we think of it as a slope, e to the b is going to be less than 1. So if my regression coefficient, if my regression coefficient is negative, and e to the b is, say, 0.5, then a unit increase in my odds are 0.5 what it used to be. It's half. Another unit increase, the odds are half again. Another unit increase, the odds are half another time. So my odds are going down and down and down, kind of getting more and more negative. But notice the regression coefficient can be greater than 0. The regression coefficient can be less than 0. But the odds ratio, just like we saw at the start, in that sense, even with logistic regression, the odds ratio cannot be less than 0. Odds ratios will run from 0 to positive infinity. And instead of 0 being the value of no effect, indicating no effect for the regression coefficient, for an odds ratio, 1 means no effect. 0 to 1, values of odds ratios between 0 and 1 mean that the odds are getting smaller and smaller and smaller for the outcome. Odds ratios from 1 to positive infinity indicate the odds are getting greater and greater and greater. Note that there's that symmetry. There is a symmetry with the odds ratios, just like we saw before, between an odds ratio of 5 and 0.2 are kind of the same effect. The same applies here with logistic regression. If e to the b is 4, would indicate that the odds increase by a factor of 4 with every unit increase in whatever the predictor is. If we take the inverse of 4, or 0.25, a unit decrease going the other direction will cut it to 25%. We'll cut it by a factor, divided by 4, or multiply it by 0.25. An odds ratio of 4 or an odds ratio of 0.25 are of the same magnitude, just in different directions. So it's you have to kind of do the inverse. An odds ratio of 10, an odds ratio of 0.1 is just as extreme as an odds ratio of 10. It's kind of, which direction are you going? I'm going this way, it's a 10. Going this way, it's a 0.1. If you flip whatever your outcome is, I'm going this way, it's a 0.1. I'm going this way, it's a 10. It's the same magnitude, but it's the inverse instead of the positive or negative sign. The odds ratio, I should have put this slide earlier. What's fundamentally different with odds ratios too, or with logistic regression, is that the odds ratio effect is multiplicative in logistic regression. notice in multiple regression, when we say, the B, that's the unit increase, that's the increase in whatever your outcome is. So if I work one more hour a week, how much my GPA goes down? 0.1. I work another hour, my GPA goes down 0.1 again. I work another hour, my GPA goes down 0.1 again. So it goes down 0.1 to 0.2, 0.3, 0.4. Right? It's additive. With logistic regression, it's multiplicative. If my odds if my odds ratio is 3, if e to the b is 3, a unit increase in x, my odds triple. Another unit increase in x, my odds triple again. It triples from that last triple. So it's 9 times what it was 2 units ago. I increase the odds ratio, I increase one more, it's 3 times 3 times 3, now it's 27 times. So odds ratios can get the effect, the odds ratio of 0.3, the effect can get very big very fast. So and that's where the scaling comes into effect. If my scale is, if I'm looking at, let's go back to the example, I'm looking at schooling, how much schooling did the parent get, and I measure schooling in days, that odds ratio is going to be really small for 1 day of extra schooling, right? But on the other hand, if it's like 0.0001 for 1 day times 1.001 times 1.001 times 1.00, for day after day after day after day, as you start to multiply a lot of changes in x, it can get very large. So it's tricky to just look at the odds ratio. You need to kind of look at what the range of x is and look at that cumulative effect over that range. An odds ratio of 1, an odds ratio of 3 when the scale goes from 0 to 2 means it's, you can go 3 times 3 times 3. May seem huge. On the other hand, another variable may have an odds ratio of 2 that can go from 0 to 10. And those 2's are going to add up. Doubling 10 times is going to add up more than tripling 3 times. So it's a little trickier to interpret. And kind of having variables on similar scales for your independent variable can help to make the odds ratio magnitudes a little more aligned with each other, kind of across that range. But this is where people mess up. I think it's an easy one to slip and think that, oh, I've gone from 0 to 3. If my odds ratio is 3, it's going up 369, not 3927. Important point. You do a logistic regression, kind of here's some output that you'll often